Hello there, Nareg is here. Today I'm going to talk about the part related to power of real numbers. So, what do we mean by power of real numbers? Whenever we have a certain number, let's say that number is a, and a is multiplied by a times n repetition, let's say n factors, we will be able to talk about a to the power of n. So this is how you simplify this expression, which is a times a times a with n factors. You simply say it's a to the power of n. Now, what is a? Of course, a, it represents the base. As for n, it represents the exponent. Okay, so n is the exponent. That's why we say a to the power of n. So I'm gonna take a few examples, but first I'm gonna also talk about some particular power of real numbers. So whenever you have a, which is different than 0, you're willing to find a to the power of 1. This is equal to a, because we can say that it's the same thing as 1 times how many repetitions of a? 1. So 1 times a. The same things goes to a to the power of 0, which is 1. In this case, it's 1 times how many repetitions of a? 0 repetitions. That's why it remains 1. Okay. Another relation that is also important, whenever you have a to the power of minus n, you can write it down as a1 over a to the power of n. Now, in most of these cases, we are taking n belonging to natural numbers. Now we're going to see that n could be real numbers. Even it can be a real number. It could be rational, it could be irrational, so it doesn't matter. But in this case, we're simply using n, a certain number belonging to the natural numbers. Now let's take some few examples. So the first example, we have, let's say 3 times 3 times 3 times 3. As you can see, we have a repetition. 3 is repeated 4 times. The multiplication is repeated 4 times. So it's 3 to the power of 4. Now what about 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3? Again, it's 1 over 3 multiplied by 1 over 3 and having this multiplication repeated 4 times. So you can simply write down that it's 1 to the power of 4 over 3 to the power of 4. 1 to the power of 4 is 1. 3 to the power of 4, we're going to keep it 3 to the power of 4. Now this answer could be written also in this way, 3 to the power of minus 4. So as you can see, we are already talking about a negative integer. Right? So it's not simply n belonging to natural numbers. It can also be any real number. Now what about Another example, let's say we have 3 to the power of 1. So in this case, you simply say that it's 1 times 3 is repeated how many times? Once. So it's 1 times 3, it's 3. So this is the answer. What about one final example? 3 to the power of 0. Again, it's 1 times how many repetition of 3 do I have? 0 repetitions. So the answer will remain 1. Alright. So these are a few examples in order to talk about the power of real numbers. Now I'm gonna study the sign of power. The sign of power. So let's talk about the sign of power. When we have a to the power of n, if a is positive, no matter what the value of n, of course n, in this case I'm gonna talk about n, it belongs to the natural numbers. Alright, n belonging to the natural numbers. Natural numbers are 0, 1, 2, 3, 4, 5, etc. So if a is positive, a to the power of n will remain strictly positive. Alright, I'm gonna take a few examples, you're gonna see. Now, if a was negative, now in this case, you have to check your exponent n. So if n is even, a to the power of n will remain positive when n is even, and a to the power of n, so this is the second option, a to the power of n will be negative when n is an odd number. Alright, so let's take a few examples and we're gonna discuss about them. So some examples, let's say we have 3 to the power of 2. As you can see, the base is 3, it's positive. The exponent, it doesn't matter. 2 is even, it will give you plus 9. Let's say we had 3 to the power of 3. Again, 3, the base is positive. Even though your exponent is odd, the result will remain positive. Alright. Now let's take a negative. What about minus 3 to the power of 2? So minus 3a is negative, n is even, the result will be positive, a to the power of n will be positive. Now minus 3 to the power of 3 is equal to minus 27. It's minus 3 times minus 3, which is 9, times minus 3, it's minus 27. So a to the power of n will be negative. What about, again, let's take some other examples. Minus 3 to the power of 4. Minus 3, the base is negative. What about the exponent? It's even, so it will remain positive. It will be plus 81. Minus 3 to the power of 5. So minus 3, the base is negative. The exponent is odd, so it will be minus 243. A couple of other examples. And what about 1 to the power of 2? It remains 1. What about 1 to the power of 3? It remains 1. So it doesn't matter. If the base is positive, the exponent is odd or even, the whole part a to the power of n will remain positive. Now, in case we had minus 1 to the power of 2, it will be 1, and minus 1 to the power of 3, it will be minus 1. Alright? So, this is how you study the sign of your power. Now, what are the properties related to the power of real numbers? Let's go and talk about the properties related to the power of real number. The first one, we have a, so this is the first one, a to the power of n times b to the power of n. It can be written as a times b to the power of n. In the same way, when we have a to the power of n times b to the power of n times c to the power of n is equal to a plus a times b times c to the power of n. So let's take directly some examples. The first one, let's say we have 3 to the power of 2 times 5 to the power of 2. In this case, it will be equal to 3 times 5 to the power of 2, which is 15 to the power of 2. What about 3 to the power of 2 times 5 to the power of 2 times minus 2 to the power of 2? Again, it will be 3 times 5 times minus 2 to the power of 2. So it will be equal to minus 30 to the power of 2, which is 30 to the power of 2. Alright, this is the first property. Now, what about the second one? We have a to the power of n over b to the power of n. It can be written as a over b, the whole part, the whole fraction to the power of n. An example, simple example. So whenever you have, let's say, 3 to the power of 5 over 7 to the power of 5, you can write it down as 3 over 7 to the power of 5. Alright? Now, the third property, we have a to the power of m times a to the power of n. In this case, you write it down as a to the power of m plus n. And similarly, when you have a to the power of m times a to the power of n times a to the power of p, you can write it down as a to the power of m plus n plus p. Now, let's take a few examples. What about 3 to the power of 4 times 3 to the power of minus 7? So I'm not taking n, the exponent, simply natural numbers, so I'm even taking negative integers. So it will be equal to 3 to the power of 4 plus minus 7. So it will be equal to 3 to the power of minus 3, which can be written as 1 over 3 to the power of 3. Alright. Now what about 3 to the power of 4 times 3 to the power of 7 times 3 to the power of 1 over 2. I'm even taking rational. We're going to discuss about rational exponent later, and of course it will be in the video related to the nth root of a certain number. We're going to discuss it later. So in this case you can write it down as 3 to the power of 4 plus 7 plus 1 over 2. So it will be equal to 3 to the power of 8 over 2 plus 14 over 2 plus 1 over 2. Alright, so it will be equal to 3 to the power of 23 over 2. Alright, let's go to another property. When we have a to the power of m to the power of n, it's equal to a to the power of m times n. So I'm going to take an example. Let's say we have 3 to the power of 3 to the power of minus 2. You can simply write it down as 3 to the power of 3 times minus 2. So it's 3 to the power of minus 6. Alright? Of course, 3 to the power of minus 6, it can be written as 1 over 3 to the power of 6. Alright? Now I can add a simple remark here. In case you had a to the power of m to the power of n, a case like this, you have to take m to the power of n. I'm going to take an example. So an example related to this one. Let's say we had 3 to the power of 3 to the power of 2. It means that you have to take 3 to the power of 9 and not 6. Whenever you have the parentheses, it's like previously in this case, you simply multiply m by n. But in case it was a to the power of m to the power of n, it means that your exponent is to the power of 2. So it's a case like this that you have to simply say 3 to the power of 3 to the power of 2 is 3 to the power of 9. Alright, now I'm gonna go and take one last property. So in case we had a to the power of m over a to the power of n, very simple, you can write it down as a to the power of m minus n, or you can simply say that it's 1 over a n to the power of n minus m. Let's take some examples. So I'm going to take a few examples. Let's say we have 3 to the power of 4 over 3 to the power of 5. You can say that it's 3 to the power of 4 minus 5. So it's 3 to the power of minus 1, which can be written as 1 over 3. Now what about 3 to the power of 4 over 3 to the power of 4? Of course it will be 3 to the power of 4 minus 4. It's 3 to the power of 0, which is 1. Now the last one, let's say we have 3 to the power of 4 over 3 to the power of 3. In this case, it's 3 to the power of 4 minus 3. So it's 3 to the power of 1, which remains 3. Alright? Now I'm going to talk about the powers of 0. So in this case, we're going to talk also about the part related to the powers of 0. So how do we have So this is the part related to the powers of 0. How do I have a to the power of 0, 1? Very simple. Let's say you had 2 to the power of 1. You can write it down as 1 times the value. It is repeated how many times? The value is 2. It's repeated once. So it's 2, which is 2. 2 to the power of 3, it's 1 times. 2 is repeated 3 times. 1, 2, 3. So it's 1 times 8, 8. So similarly, when you're going to do 2 to the power of 0, you still have 1 times the value that you are going to multiply is 2, but it's repeated 0 times, so it will remain 1. And whenever you're going to talk about, let's say, the value 0, 0 to the power of 1, let's say, it will be 1 times, how many repetitions of 0 do I have? Once, so it's 0. 0 to the power of 4, let's say, it's 1 times 0 times 0 times 0 times 0. I have 4 repetitions, this multiplication of 0 times 0 times 0 times 0, the result will be 0. But as for 0 to the power of 0, you still have 1, and the repetition, you do not have any repetition, so the result will be 1. Or you can simply say it's not defined, it's undefined. Alright, so this was the part related to the powers of 0. You simply have to keep in mind that 0 to the power of n, and when n is positive, it will give you 0. Alright, 0 to the power of n, and n is positive, strictly greater than 0, it will give you 0. The integers should be positive. Now I'm going to talk also about the scientific notation. So what about the scientific notation? Whenever you have a certain number, and you can write it down as a times 10 to the power of n, where a is a certain value between 1 and 10, so you will have the scientific notation. Example, let's say we have 5, 1, 2, 0, 0, 0, 0, 0, and I want to write it in a scientific notation, so you have to write it down as 5.12 times 10 to the power of, you have to count that you have 7, so 10 to the power of 7. Now what about 0.000021? It will be equal to 2.1 times 10 to the power of minus 5, and this is how you have your scientific notation. And the last remark that I would like to give you, it's related to the rational exponent, whenever you have a rational exponent. So in case you had a to the power of m over n, this can be written as the nth root of a to the power of m. Alright? I'm gonna talk about this part in another video related to the nth root of a certain number. So I can give you a couple of examples related to this rational exponent. Let's say you have a to the power of 1 over 2, so it's square root of a. You should simply say that a should be positive or 0. Example, the 3 to the power of 1 over 2, it can be written as the square root of 3, which is radical 3. Alright, so this is related to the exponent, which is rational. That's all for this video related to the power of real numbers. I'm gonna ask you to subscribe to my channel, and of course you'll be notified whenever I upload new material, new videos. I can also share with you my Instagram and Facebook account in case you want to contact me, or you can simply leave a comment below. That's all for today, and see you next time.